God, I hate the fact that this thing moves all over the place. Transform. One. Hey everyone. We're gonna start the stream a little early for people to join us, and so that it's not saying that stream is starting soon. If you see our faces, that means we're about to begin. So my name is Morgan. I work at Decentology. I am a software developer, and with me today is Jacob. Say hi.
Hey everybody. Yeah, my name is Jacob. I'm also a software developer at Decentology, and happy to be doing these Flow developer hours with Morgan as always.
And for some reason, you just went away, and you're a black screen, my friend.
Vaporized.
Since we have a minute to spare, I'll try and redo this. How many people do we have in the chat? Amal, hey Amal. Hope you liked the office hours yesterday.
Got 4 people tuning in. Awesome.
Yeah, we're gonna ramp these numbers up. You just watch.
Yeah.
All right, so we got a size and position is weird. So I'll just reset the positioning. This is OBS, by the way. A lot of streamers use this stuff for...
Yep. Yeah, I love OBS. I used to always use it when I would stream gaming content.
All right. Just making sure, everyone in the chat, please let me know if you can hear Jacob, even though you can't see him. But we just...
Hey everybody. Just testing if you can hear me. And welcome everyone that's in the chat.
BZ, hey my man.
We got BZ, hey Aditya, and Melwin.
Someone please give a thumbs up or a thumbs down or yay or nay if you can hear Jacob. And we'll proceed with all the good stuff. Yeah, sweet. All right. So moving on into the screencast. Jacob is on here, even though he's miniature, but you know, he's a big man. He can handle it. All right. So here's the plan. Yesterday we took a peek at a little bit of cadence code. We saw some structs and basic types and things like that. But today we're gonna reel it back a little bit and we're gonna talk about the Flow CLI or the command line interface and the Flow playground. And we're gonna start with the Flow playground. This is, let me bring up the browser. Here we go. So you can find it by going to this link. I'll try to increase the font a little bit. So Flow Playground, what is it? Well, it's an emulated environment where you can execute your cadence contracts and interact with them with the help of transactions and scripts. It does have a basic account system and a little bit of freedom when it comes to deploying and redeploying. It's not the full thing. You can deploy multiple contracts per account, but we'll discuss all of that in a little bit. So first off, I'll give you a tour of the layout here. Top left, you'll see a list of accounts. It's always 5, and that's just the way it is. With these 5 accounts, you can interact, you can deploy contracts, 1 contract per account, and you can use the account storage. With Flow, everything that exists on Flow exists with an account, specifically with that account's storage. And to the right, you have the editor window. I'll just go ahead and delete this and say, hello, everyone. In here, we'll write our contract code and transactions and scripts. We can't freely exit. Oh, sorry. I'm gonna remove the yellow tint. Thanks for letting me know. Yeah, the warm temperature. It's me. Sorry. Hurts my eyes when I do it without it, but for you, for everyone tuning in, this is the kind of sacrifices that we're willing to make at Decentology. All right, so yeah, we can't write something as free form as we did yesterday or the day before rather, and just execute it. We need to put things in the context of a contract, a transaction, or a script. All right. So what's a contract? Jacob, let us know. A message. Sweet. That's a awesome explanation, Jacob. And it's really no more than that. It's a collection of code. You can think of it as a program. You can think of it as an instance of a class, or rather a class definition, where you can have instance of, basic premise here is that we're going to put some logic in there, and that logic will be executed against some accounts. So we created a contract, named it Jacob Talks, and there's a message, and hopefully, if you can imagine something of a concept here, that this message is going to be spoken by Jacob. So it's an exciting thing. I want to see it live, and let's put some messages into Jacob's mouth. So how do we do that? Well, first we have to deploy this contract with an account. Otherwise, it's not going to exist anywhere. It's not living on its own. So we hit this deploy button here. It's simplifying some things. And once we're ready, failed to deploy. All right, so this is a beautiful example of how Flow Playground, even though it's a really nice idea, it oftentimes breaks. All right, so if it breaks, don't worry, don't fret. Open up a new tab and try and do it again. Oh, sorry. Really? Jacob? Oh dear. Test. Let me see. Yeah. That should do it. All right. So Jacob mentioned that a contract and these growing pains are incredible. So Jacob described the contract as a program where you put some logic in there and lives in the blockchain, and we can execute against it. All right. So we go ahead and deploy this contract by clicking deploy. You can redeploy it, although it resets account storage by clicking redeploy. And there's absolutely no reason for you to be afraid of clicking anything or breaking things. This is the playground, right? This is the place to break things. All right, Jacob, so we have self.message initialized to test, okay? And we want to update that. What would be your recommendation for updating?
Sure, yeah. So like I was saying before, if a contract is a sort of a rule book and we think about it in terms of like that, then we should, write a rule to change this message. So what we can do is we can add a function, and the way we can do that is, underneath that message, we can do public fun, that's the abbreviation for function, and then we could add a function name, which we can call update message or something. And then we'll have it take in a parameter, and that parameter will be the new message name that we want to set it to. So we can call the parameter, I don't know, we could just call it new message and set that to a string, because that's what we're going to update to, that's what we're going to update the message to be. And then we're not going to return anything, because all this is going to do is just update the state variables. And so we'll just set, like you see Morgan doing on the screen, self.message, which is the state variable defined above, to this message. And we can, do this through a transaction that Morgan will show you in a sec here.
All right. So after any update that you do to your contract in Playground or on Flow in general, you got to redeploy. I'll show you how to do it in the terminal command line interface afterwards. But for Playground, click redeploy. It's a concept that's really user friendly when you think about it, and it's something new to blockchain with Flow. All right, so we have this update message, and we have to think of how to interact with it. Now, there's two choices. One is send a transaction or execute a script. Now, something to put in your mind when deciding between the two is a question: does this operation mutate the blockchain? And if it mutates the blockchain, then you're going to do a transaction. If you're reading from the blockchain, then do a script. That's pretty much the determining factor there. Would you agree, Jacob?
Yep, totally agree.
All right. So in this case, we're going to be updating a message, but Yeah, so let's create a transaction if we want to update a message. So I clicked on transaction in the playground. I want to rename this to update message so that it's clear what it is and what it does. And we have the transaction editor open. First up, when interacting with a contract, we got to let Flow know what exactly the contract contains, functions, fields, you name it. Those need to be accessible within the scope of your transaction. So Flow provides an import statement where we define the name of the contract and where we are importing it from. Our contract is called Jacob Talks, which he does so eloquently. And we have to provide the account. All right, so the way we reference an account, we do that by using the address. And Playgrounds uses a simplified format for these. So 0x01, which is a hexadecimal format for a number. And we can go ahead and open up a transaction body by using the keyword transaction. All right, now here's a couple of things to note. If a transaction somehow interfaces with account storage directly, then we put that logic in the Hi Violet from South Korea. That's awesome. Thanks for joining us. So how do we, distinguishing between these transaction blocks. So prepare is the place where you interact with storage. You add to it, you read from it. This is where you do it. In this case, we're not directly dealing with account storage because we have this update message function. And we're not interacting with a struct or anything like that. We're just changing the message. All right. So we can, kind of skip prepare and go straight to execute. And execute is where we can put the sort of the bread and butter of our transaction in. And in this case, we're going to reference the Jacob Talks update message function, and we're going to send a message. What kind of message are we going to send to you, Jacob?
Let's send, instead of hello, let's just send goodbye, just the complete opposite. Goodbye.
All right. So this interface to the right is where we select the transaction signers. So this brings up a concept. In blockchain, everything's public, right? You see the entire state. You see all the history that led up to the current state. You see whatever transaction, whatever your account has. But we need a level of security. We can't allow everyone to access everything, and we achieve that security by limiting access to accounts with the usage of public-private keys. Okay. So this public-private key thing is a cryptographic topic, and essentially for the purposes of what we're doing, all you got to know is that there's a private key and a public key. And the private key has to be secure. You got to keep it to yourself, not share it with anyone. And a public key is something that you can share and is publicly accessible on the blockchain. Using those keys, when someone wants to execute this transaction, they essentially build it into a binary format and then sign it with that private key. Then Flow, a node on the Flow network, takes that encoded information and tests it against your public key. If there's a match, then that means this is an authorized transaction and it can proceed to be included in the blockchain. Otherwise, it's discarded. And this way, we achieve security and make sure that only the people that are actually authorized to access specific account stuff can do so. So this little widget here allows us to select which account are we signing with, and it sort of abstracts the management of keys for the purposes of Flow Playground. Jacob, is dealing with keys something you enjoy?
No, not at all. I despise it, but that was a good explanation.
All right, so we go ahead and select an account from this list, And let's try and send it. All right. Here's a concept that we can use. So we didn't see anything happen in the transaction results tab right here. Let's add a log to see if this went through. So start and then finish. Okay, let's send it again. Sweet. So we're using log in the playground and in the emulator to help us as developers navigate our code and see and debug it and see what's working, what's not working. Okay, so we updated the message and perhaps we want to read it. So what would be a good way to read, Jacob?
Yeah, so like Morgan was saying earlier, if we run a transaction, that's because we are changing something on the blockchain or we are changing some sort of state. But in this case, all we want to do is just read that information, right? So what we can do is go to the script and we can just run a simple script that reads that variable. And we can do that just by, the Flow Playground automatically gives us this kind of format that's set up with the public function main. And like Morgan was showing us before, if we just import that Jacob Talks contract and we just access that message that's defined in the contract at the topmost level, we can actually log it or even return it.
That's what we're going to do. We're going to return it. And that message is contained directly in the contract, so we don't need to access any account storage, and it's should be readily available. So now let's agree, Jacob. If you see a message, okay, you say it out loud, because this is what the contract does, and we have to comply with the contract, right?
Yeah, I will. Yeah.
All right, what's the message?
I'm waiting for the stream in 3 seconds, but I'm sure it says goodbye.
Here we go. All right, people in the chat. We have 11 people in there. Let's pick a message for Jacob to say. Pick something good. We need suggestions. Come on. Someone come up with a good one.
Yeah. And for the 11 people we got in this chat, let's hear some awesome suggestions.
All right, we got one. Hi, everyone. With a smiley face. It's a good one. Pleasant, kind. I like it. Anything else? Anyone else? While we wait for suggestions, when La Liga for Flow. Okay. Someone's reading up with the news. While we're waiting for those suggestions to come in, we have to. Let's, update our transaction to make it smarter so that we don't have to update the source code every time we want Jacob to say a new message. Let's add an argument, okay? So the way we add arguments to transactions is pretty much the way we add arguments to anything on Flow. We open up the parentheses next to transaction, and while Jacob is monitoring the chat for what he's going to say next, we're going to implement the functionality to enable that. So we're going to take in an argument that says message. It's going to be of type string. Okay. And as you can see, this widget now has a text field where we can provide the message that we're going to send. And to fully complete this update, we just include it into the function call. And we're going to run a quick test with the message test. All right. It's sending. I think I need to provide quotes around it. All right. Yeah, quotes. So don't forget, if you're sending a string, make sure to wrap it both ends with double quotes. All right. And then we go ahead and read the message. Did it update? Yes, it did. It does include quotes now because Playground is a little wonky at times, but that's fine. All right.
Test.
Loving this. All right, Jacob. So what's the winner?
Well, I think the winner, it kind of goes with my theme here. Jacob is cool from Amal.
Jacob is cool. All right.
Yeah.
Amal, thank you for this kind message, and we're going to read it out loud for everyone's pleasure. All right, so we send this message, wait for it to finish, we call read, And we have a contract that says, Jacob needs.
Boom. So Jacob is cool.
Well done, everyone. Well done. Thanks for participating. This is great. All
That
right.
was fun.
So thank you, Jacob, for your great job. And we sort of played around with the playground a little bit. We get to see that you can publish contracts with accounts. We can sort of iterate a little bit on what we do there, and then redeploy contracts. And we have transactions where we can update the state on the blockchain if we want to, and we have scripts when we just want to read. So that's a simple thing. There's tons of tutorials that you can follow and implement NFTs and tokens and whatnot. But for our purposes, we're sort of done with the playground for now, because I really want you to anchor your thought process of how Flow works by going a little deeper. Since we're all developers here, we want to get our hands dirty a little bit, and we want to work directly with the interfaces. So we're going to explore the Flow CLI. All right. So how do we do that? Where do we start? We go to docs.onflow.org. To the left, you'll find Flow CLI. And there's some steps how to install this thing on whichever operating system you're on. This is something I'll leave to you personally. It might be a chore to do. It might be easy. It depends. And this is something that you won't be working like directly a lot, but this is something that you need to figure out. Although I have to mention, maybe Jacob could give a better sales pitch than I can. Decentology does take care of the hassle by something we're launching pretty soon, or have already launched in public, and that's containers, right, Jacob?
Yeah. So, when you go to do this sort of setup, you'll need to download the Flow CLI, and you need to get a bunch of other stuff that can be really annoying as setup. But one of the great things that we're doing at Decentology, our main product called DAppStarter, which helps you get started coding on the blockchain in a matter of minutes. We now have a containerized solution where you actually don't need any of these dependencies on your computer. You can simply just launch the container, and it'll load a full stack application on your computer, and you don't need any dependencies at all except for Node. So very helpful in getting started.
It's extremely useful, and you'll get to experience installing it locally, and hopefully that's not a chore. But if you get into any kind of trouble, feel free to create a project with DAppStarter, and we'll get you guys sorted out. So what I'll do now is I'm going to launch my terminal. Okay, bump it up so that it's legible. All right, maybe this size is good. If we're going too small, people in the chat, please let us know. Easy, you're always on point with that, so I'm counting on you. And we're going to open up the good old VS Code to help us out. All right, so we have sort of a blank slate here, and we want to get going as soon as possible. We want to write some stuff. We want to see it live. So how do we start? Well, when you think about the CLI, it interacts with a baseline configuration in your system for connecting to any of the many Flow instances you can sort of think of. And so we need to initialize that configuration, and that configuration is per project. It's something that you can define individually, but you initialize it with the flow init command. Flow init will be available as soon as you set up your Flow CLI. And after we run this, we can see in the editor that we have a Flow CLI or Flow JSON that contains a bunch of information on the networks and the accounts. Okay, so that's sort of the first part. We initialize our project by running flow init. Okay, now we want to replicate a little bit the experience that we had in the playground. I'm going to launch that again, where we have a number of accounts and we can interact with them, launch contracts, deploy contracts, and that kind of thing. So we need to do a couple of things. First one is create those accounts. All right, so I'll go ahead and launch the emulator. The emulator, by the way, is a place where we can locally develop Flow with Flow. It's like a testnet, but for your own use. It's not accessible online, but it's a quick way to interact with the blockchain, and it's equivalent to the testnet in every kind of functionality that you can imagine. So Flow CLI provides us the emulator, and I'm going to start it, and I'm going to use the persist flag. So the emulator by default, once you close it, it deletes everything, the current state of what you had previously. And for our purposes, it'd be nice to persist that data. On top of that, we're going to use the -v flag. Jacob, can you elaborate on what that does for?
Yeah, so the -v flag, essentially what it does is allow verbose logging. And what that is it will log to the console the logs that we put in our transactions, scripts, or contracts. So that's kind of what you saw in the Flow playground, where Morgan was logging and it would show up on the bottom side of the playground. So if we enable verbose logging, you'll actually see that in the terminal. And other stuff like events and stuff like that, which we'll see in time.
Yep. So it's a useful thing to have, and as developers, you should always go for more explicit understanding of what's going on behind the scenes in your code base. All right. So let me just organize this a little bit, and so it's easy to read for y'all. Cool. So we have the emulator started. It's running, and we have VS Code here to the left. So we want to create some accounts. It's a great thing. So going back to what I mentioned about keys is accounts, they require a key. Without a key, you can't authenticate, and the account is basically on autopilot if it doesn't have a key. So we need a key first. Thankfully, Flow CLI provides us with a key generator, and you can call it by running the flow keys generate command. And optionally, you can provide a signature algorithm. There's 2 of them available with Flow. This is the one I picked because that's the one that's default for Bitcoin. And if you guys like Bitcoin, you might as well decide to pick that signature algorithm too. All right, so what this command does is it generates a private and a public key based on this algorithm. We don't need to dig in too deeply on how these are generated. They're elliptic curves, but that's math, and we're developers. So we'll go ahead and just use this generated information in our code. All right, so how do we create an account? Well, there's another command, and I'm gonna create another file, call it actions.md. So let's generate an account. Okay. So this is the command that we run to generate an account. We give it a key, we give it a signature algorithm, and we give it the signer. Okay. The Flow CLI emulator starts with an account already in there. It's called the emulator account because without an account, we can't run any transactions. So it's kind of bootstrapping it for us. So we just give it a key, and the key that we need is the public key. We don't feed it the private key, we feed it the public key that we just generated. And we're gonna get an account address. All right, so we did get it in the terminal. Now, Jacob, do you know how Flow generates these account addresses?
To be honest, not 100% sure, but I do know that it uses the public and private key. So what happens is, when you actually create an account here with the public key, I believe that the private key is generated from the public key. Is that correct?
That is correct for Ethereum, but that's incorrect for Flow.
Oh, well, there you go. See, I'm very experienced.
With Flow, what you have is with Flow, what you have is a sequence. That means the internal state of Flow maintains a certain sequence of account IDs, and with every key that you add with the create account transaction, the next one is given to you. Okay, so we can, vanity account addresses don't exist. We can't really generate a specific key and get an address from it. We just have to sort of work through it. Yeah, so an account address is only given to you once you send the create account transaction to Flow. All right, so now we have an account address, we have a bunch of keys, and we're ready to go with updating our flow.json. So flow.json is a very useful tool for helping our CLI journey, because we don't want to feed it everything every time. We just want to use some shorthands. And we start by creating and adding another entry in the accounts dictionary. So we have emulator account in there, and we're just going to add another one. Let's call this Bilbo. If any one of you is a Lord of the Rings fan, you'll know what I mean. Now pay attention to this format. This is the account address, but it's missing the 0x prefix. Okay, so if anything goes wrong, you might want to check if you have the 0x prefix in the flow.json, because you shouldn't. Okay. All right. So what do we need in this account definition? Since we did use a custom key, we need a different. If we use the default key, we could just feed it the private key and call it a day. But for our case, we need to define what type of key it is and what kind of algorithms that we use to generate it. So while I'm typing this out, Jacob, would you like to share your experience with Flow.json?
Sure, yeah. So the Flow JSON has definitely developed over time, but it has gotten easier in the sense that you can see that the layout isn't too hard to read. Essentially, you start out with this emulator account, and that's just the service account. So that F8D6E, what you see there, that's just what like Morgan was saying, the account that's generated for you, and it's already there, so you can do stuff like account creation. But then once you create your new accounts, you would do what Morgan is doing, where you give it a name and an address, and you do all this fancy key stuff. And you're doing this key stuff because you generated this account yourself.
Sweet, thanks for that. And I'm done with this body right here. So now we have an account Bilbo. It has an address and it has a specific key, and we can start interacting with it. And the first interaction that I want to do is I want to deploy a contract. All right. So for if we want to deploy a contract, we better have a contract. So I'm just going to create a folder, call it contracts, and let's make a similar concept. Let's call it messenger CDC. Okay. And what we're going to do is we're going to declare a pretty blank contract so that we can just deploy it. All right. So we have an initializer and it does nothing. Okay. So pretty empty body. This is for the purposes of just deploying this. All right. So to deploy it, we go back to our Flow.json and we update the contracts dictionary with a contract name and the path to it. So the path is contract/messenger.cdc. All right, we're almost done. Not quite, but very close. Last thing is we update the deployments dictionary. The deployments dictionary works like this. So there's 3 layers. Top layer is you say which environment you're dealing with. There's 3. You got your emulator, your testnet, and your mainnet. Each one is a dictionary. Then you go ahead and provide a reference to the account. So Bilbo. And then the bottom layer is a list of contract names that you're referencing in your contracts dictionary. Okay, so messenger. So now I believe this completes the Flow JSON with all that we need to deploy a contract. With the emulator running, let's expand this a little bit. With the emulator running, we're going to go ahead and do Flow project deploy. Boom. We got deploying one contract. It went successfully.
Nice.
There's the name, there's the account address, and there's the transaction ID. All right. So we have deployed a contract, and that's a great step on your journey to becoming a decentralized app developer. And we're done. No, I'm kidding.
That's great.
we're not done. We're gonna do a little bit more. But yeah, Jacob, how do we list all the contracts that have been deployed with an account?
I'm not 100% sure. Or do you mean?
Well, we can go to docs.play on Flow, right? And look at cadence, language reference, and we're gonna look for accounts. All right, let's see. Public account. It has an address, it has a balance, blah, 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 and contracts. Okay. Well, let's see what that is. So since we're reading, we're not writing, we can create a script. Read contracts, CDC. And in here, since we're not really interfacing with any specific contract, we're working with the basic stuff here, the standard library, right? We can just start writing our transaction. So transaction, and what we're gonna do is we're gonna provide it. Oh, sorry, this is a script. What am I doing? Jacob, you didn't catch me while I was making a fool of myself.
It just hit my stream.
All right, so this is a script, and all scripts have to have a main, and that main is the entry point for the script to be executed. All right, now that main is going to take in one argument, and that argument is going to be the address of the function, or rather the account that we're going to look up the contracts for. So a little bit of sort of standard library stuff. We take the account by calling getAccount, and we feed it the address that we sent our script. What else do we do? With the account, we can look up the contracts. Let's see. Account.contracts. And we can try and log this. Okay, so read contracts is there, and blah, 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 blah. Okay, so we did deploy our projects with the Flow project deploy command. How do we execute a script? In the Flow Playground, it was easy, right? You click a button, boom, boom, it's there. With the CLI, it's a little bit more complicated, but not too much. So we go into our actions MD and just add another note for execute a script. All right, so what's the command? Well, the command is flow scripts execute, and then we provide the address. The address we can find inside of our flow JSON. Close this out and feed it in. Now the scripts, script name is read contracts and .cdc. So here's the thing. Read contracts takes in one argument. Okay, it's of type address. Type address just means, you know, this little thing, 0x, whatever. The hexadecimal format for an address. And it takes in one argument. So the way you feed arguments in the CLI is you essentially, after you provide the path to your script, you start feeding verbatim the literals of your arguments. Okay, and in this case, we have the address. So let's go ahead and try and execute this. Unknown member. All right, so contracts, I believe, is not yet fully deployed. So, let's grab something. Let's look at the balance. Working with the bleeding edge. All right, so we have a question in the chat. That's on Slack, actually, in the Flow developers. Jacob, can you help me out on that one?
Yeah, sure. So the question is, don't you need to import the address? Let me go back to the stream. So inside the read contracts.cdc script, are we importing the? Well, let's see. It's a little delayed. Oh no, so I don't think we do. No, because we're not actually calling anything on the contract itself.
That's correct. The thing to keep in mind is there's a standard library that Flow has, and it has some types and some functions and some basic stuff that's always available. You do not need to import what's available. However, if you're working with a contract, if you're working with something custom, then you need to import stuff, and you can import 1, 2, 3, however many contracts that you need that you're working with. We're working with the standard library right now. So what this did is, I'm going to rename this so that there's no confusion here. This is not reading contracts. This is reading the balance of an account. Okay, so we read a balance for, we changed the name. We got to change it. I'm also going to change this so that we're returning the balance, which is a ufix64. And we're going to return it, and we're going to log it so that people can see the distinction there.
Yep, and I do have to give my notice that I have to run here, but I will see you all in the next one, and please stick around with Morgan to finish this exercise. So thank you, everybody.
Thanks, Jacob. It's always a pleasure to have you. Godspeed and good luck.
You too. Thank you, Morgan.
Bye.
Bye.
All right, so now with Jacob out, we're just going to continue together and finish up what we started. So now we would just want to see what happens when we execute a script that reads a balance. So two things. In our emulator terminal, we can see that the balance is 0.01 or 0.001. And in our terminal where we executed the script, we have a result as well. So if we just logged it inside of here, then this information wouldn't be accessible to someone that's using it. For example, you're building a website that reads out the NFT collection that someone has. Okay, so that will probably be a script that will have a return statement, and they will display it in the JSON, or rather in a Node.js project or a Python project, whatever you're working with. So you need to return from your script to have it accessible wherever you need it. If it's just a log, then you can see it in the terminal for the emulator, but that's about it. So that's the distinction there. Logging is good for debugging, but inside of scripts, make sure you return stuff from them. All right, so let's go ahead and make a little update to our messenger contract so that it's more fleshed out. And going back to what we spoke about during the last developer hours, and that is composite types, so structures and that kind of thing. I'm going to refactor in my screen a little bit. Okay, so we're working with types and we're working with composite types, and the basic composite type that's pretty familiar with everyone, or at least should be, is a struct. Essentially some kind of object, right? So we have a messenger contract, and we want to send messages. So pick a good name. Message is a good name, and that message is going to contain two things. It's going to contain some kind of record of who's the sender, and on Flow, senders are every sender has an address, or rather every account has an address, and a message can be sent by an account. So that's what we're going to record. We're going to record an address. All right, and then we're going to record the contents of the message, which is a string. And we're going to use an initializer where we set both of those to what we receive when someone initializes a new message. All right, so we're going to have a sender address and some contents. That's the string. And self.sender. Again, remember, self references the current instance, and we set it to whatever we get in the parameters. These are named parameters, by the way, if you recall. You know, if I added an underscore, these would not be named. Yeah, a little refresher there. All right, so self.contents equals contents. Sweet, sweet, sweet. So now we have a message. We have a concept of a message. Ideally, we want to receive multiple messages. That's the concept of a messenger. So we have to store them somewhere. And the best place to store it is to create another structure. Let's call it inbox. And let it have an array of messages. Okay, so message is going to be an array of message. Alrighty, so now since we're working with a basic inbox, when you create an inbox and it has no messages, we don't need an initializer that has any kind of arguments. So we just initialize it to an empty array right here. Sweet. So now we have a message and we have an inbox. We just need to add a function that will help us create an inbox. Okay. Return an inbox, and that takes no arguments. And this is sort of going to help us adding people on board to this messenger contract that we're building. Alrighty, so in this case, we will be interacting with storage. We will be storing this inbox in account storage. And when you're interfacing with storage, there's really three things that you need to pay attention. So account storage, here we go. Inside of the Cadence Flow Docs, Cadence language reference accounts, under account storage, you'll find that there's three different types of access to account storage. There's storage, which is the underlying storage, the direct access to whatever you're storing there. There's the private interface, so privileged interface to the underlying storage, and then there's a public interface. I'm going to show you exactly the instances of the storage and the public interface and how to work with them in a second. But you'll know that there's a path component. When you're storing something, you're storing them, for example, storage/test. And like in any kind of language, we want to be able to nail down what kind of path we're working with. We want to set a constant, so that's not something that's is bound to change or is difficult to remember. So we're going to make each individual path where we're going to store this inbox a part of the messenger contract. So we're going to do public and let's call this inbox storage path. And it's going to be storage path type. And the initializer is going to set this inbox storage path equal to storage/messenger inbox. Okay. And that's it for now. We can go ahead and start interacting with contract. First, we've got to deploy it. So who remembers how to deploy a contract? Oh, Siobhan, how do you start? Well, we're basically starting right now. We go to sites like docsonflow.org, and we're downloading the CLI. We're initializing it and so forth. So this is just really the very start of how you program out Flow. And if you go back to the very beginning of the stream, you'll see that we cover topics from the ground up, and you can follow along from there. Yeah, don't be afraid to feel like you're left behind or whatever. We're just starting. All right, so we need to deploy this contract, and if you remember, we did flow project deploy, but we get an error, right? That error says that it's already deployed, and that name is taken, the messenger name is taken, and we can't overwrite it. However, we have this update flag that updates a contract with the new source code that we just created. And when provided that flag, everything goes through nice and smooth. Sweet. So now we have our messenger contract, and it's living with our Bilbo account. I want to, let's see. I want to send a message, right? How does one send a message? Well, sending a message would probably mean adding to this messages array inside of our inbox. And we know that there's an append method with an array, so we can call that. But here's the thing. That inbox has to live somewhere, right? It has to live with an account. And for it to be able to live with an account, we have to initialize it. So we're going to create a transaction. And to make it handy, I'm going to create a transactions folder. And I'm just going to call this, let's see, what would be a good name? Add inbox. We're just adding an inbox. So add inbox.cdc. So what does it do? This transaction has to, essentially has to store our structure with the account storage. All right, so now we're going to reference a contract, and unlike the previous script, the read balance script, where we were just working with a standard library, we're going to import the contract. So we're importing messenger from. Now, when working with the emulator, you're not importing directly from the address, because that would be silly, because if you deploy this to the emulator, it has one address, deploy it to the testnet, a different address, mainnet, another address. So that gets complicated real quick. Instead, we provide it with a path to where the contract lives, and the path is relative to where the CDC file is. So see, we have this transaction folder, so we move up into contracts and then reference messenger.cdc. And we'll just go ahead and write that out. Contracts messenger.cdc. Okay? Sweet. So now that we have that accessible, we open up the transaction body and our prepare statement. So the prepare statement takes in a number of arguments, or rather a number of accounts that will authorize this transaction. And since we're adding the inbox to one account, only one account at a time, this prepare statement is going to have one argument, and that argument is going to have auth account. All right. So with auth account, we can access things like storage directly. We can start saving and reading from storage. We don't have to ask for permission. Whereas in the script for read balance, we got an account. That's a different account. That's a public account. So it's not privileged. You can't read and write to the storages freely. Alrighty, so now we have our account in the prepare statement. That means we'll need to sign this transaction by with that account. So we go ahead and create our inbox like we promised, and that's the way we're going to use that create inbox function. Okay, so now we have an inbox, and we can call the save method for that account. If you see something that's unfamiliar, always feel free to go to the language reference, and let's see here. We have our save method right here. And I'm going to share the link on YouTube just for you guys to have a reference what we're working with. So save takes in 2 arguments. The first argument is what, right? What we're saving. And then the next one is where are we saving this to? Remember what we did with our messenger contract, creating this storage path value? Well, we're going to use that for the path value, because instead, if we wrote down, storage something, then maybe another transaction would create an inbox and store it to something else. And then the system kind of breaks because there's different places to store different things. And that's why we have this notion. And this is something that the folks at Flow enforce. They want you guys to use these constants for all kinds of path instances. All right, so we save our inbox to account storage to this path. And what else? Oh, here's the thing. If we want to update our structure, our inbox, we want to push a message onto the top of the stack. Well, we could read from the account, add to the array, and then save it back to the account. But that's kind of cumbersome, and it might introduce blocking errors. So we want to avoid that. And thankfully, Flow has this concept called a capability that allows us to access what's inside of our storage without having to read from it or take items from storage. So we're going to use the capability functionality right now. To create a capability, we call the link method. Again, it's available through that link that I showed you. Funny how these rhyme. Let's see, is it there? All right, so here's the function definition, and is going to take in the path and the target. All right, so we're going to link. This public / messenger inbox path. Now, do you see a pattern? I'm using a storage path, kind of. That's not good. So let's go ahead and take this, move back to our messenger contract, and declare a new path. So this is going to be the inbox public path. Learning what's going on. Well, what's going on is we're building a messenger contract, and you guys are sort of halfway through this thing, but feel free to join. We should be having a lot of fun building this, and this is something you can rebuild after the stream as well if you rewind. All right, so inbox public path is where we're going to store the capability, and a capability is a way to access our storage without having to move items from it. Sweet, learning. So thanks for registering for the Mercury Hackathon. We just started this week. Monday was our opening ceremony, and people are starting their projects a little bit. And I got the email to attend this live stream on YouTube. Well, that's great. So one of our organizers probably sent out that email. And yeah, this is where we learn about Flow. We learn how to build on it. And we are starting with the very basic premise and basic concepts. This hackathon is about Flow and Filecoin and building NFTs using those two technologies. But before you do, we got to get some basics nailed down. All right, so where were we? We had this inbox public path constant. So we're going to use that when linking things. So we're going to link that path to a specific target inside of our storage. And that target is this storage path. All right, we did a change though in our messenger contract, so we have to redeploy it, call the same function, and we should be good. All right, so that contract is redeployed and we have our transaction finished. Now, how do we send a transaction, right? Well, kind of a similar concept to executing a script. Transaction. We're going to use the Flow CLI, and we are going to, I'm going to write it out. So flow send, flow transactions, send. Now we have to feed it the path to the transactions file. So that lives in transactions / add inbox.cdc. You can see right here. And it will need a couple of items. Do we have any arguments? No, we don't. So we don't need to feed it any arguments. We just need to sign it. Okay. Now remember this whole trouble that we went through by, creating this Bilbo account, generating a key, and so forth. Well, now we can finally use that to our advantage, and we can sign this transaction using that account. Let's go ahead and try that now. See if it works. Ooh. Oh, I made some mistakes. Not unlikely. All right, let's reset. Account.link. Oh, we need to, silly me. We need to tell Link what kind of a reference type this will be, and this will be a messenger inbox type, because that's what we're storing inside of our inbox. We got to redeploy our contract. No, we don't, because I just changed the transaction. All right, did this work? This did not work. Missing value for member inbox storage path. Did I not initialize it? I did. Let's redeploy the project, and let's try and run this again. Missing value for member. Very interesting. Let's log and see what we're dealing with. This is an unexpected error, but I guess this is a good lesson as any to find out how we debug stuff on Flow. We're going to log and see what's going on there. Let's send the transaction again. Missing value for member. Am I using, guys, am I using a do I have a typo somewhere? That's kind of fine. I'm gonna redo this and redeploy the contract. One moment. All right. Let's try and reset our emulator. And redeploy our project. And send this transaction. All right, well, what if we do /storage/ messenger inbox directly? Would that help? Maybe. And do the same thing here. Public / messenger inbox. And all right, so that worked. some reason I wasn't able to relay these things onto the transaction, but no worries. I'll have an answer for why that was the case for next session. But essentially, we have created an inbox for our messenger, and we should try and just read somehow from it. So I have another script ready that will, instead of scripts, let's create a new file and let's do read inbox. We had a read bounce, we can do read inbox. Okay, so what do we do when we want to interact with a contract? Well, we go ahead and import the contract from our contracts. Messenger.cdc, and this is a script, so we're going to do pub fun entry point, and let's see, what do we need? So we want to read the inbox for a specific account, okay, and we need an address for that, and you know what, let's just say that for now, for today, we're just going to read if an account has an inbox set up, a messenger inbox set up. So we're going to return a Boolean. All right. So how do we fetch an account? Well, we call the get account function and feed it an address. Then we try and look up our capability for the inbox. So inbox ref. The ref stands for reference, okay, but just a shorthand, and you'll see this a lot in the source code. And we go ahead and get the capability, which is located at the public/messenger inbox address. All right, we get that capability. If it exists, we're going to borrow a reference, okay. And that reference requires us to specify a type. Well, and that type is messenger.inbox, because this is what we're storing at that address. All right, so this inbox ref is either going to be null, because borrow returns an optional messenger inbox. Okay, so we can execute a simple if statement to check. Is this null? If it's not null, then we're going to return true for, this address has an inbox, or we're going to return false if it doesn't. So simple enough script, and we can try and execute it by changing a little bit inside of our actions.md. So we're going to read inbox. Okay, let's try and execute it. Clear this out. Boom, the result is true. Okay, so that means we do have an inbox set up, and our transaction to add the inbox succeeded. We didn't fail, and that's our goal. But I want to prove to you that I'm not bamboozling anyone, and this is not just going to work for every account. So we're just going to add another account just as a refresher for anyone that's joining us after we went through that step. Okay, so let's see here. We want to generate a key pair, right? Does anyone remember how to generate a key pair in the chat? I'll add a like to whoever mentions how to add generate a key pair first. What kind of command? I see my Rab is typing. All right, well, time is up. You guys were too slow on that one. That command is flow keys generate. All right, so flow keys generate gives us a private and a public key, and we're going to use that to create an account. So we take the public key and we're going to call this flow accounts create in the CLI, and boom, we have an account address and a set of private and public keys. So we go ahead and tell our flow JSON, and what would be like a good friend, a good name for Bilbo here? I'm looking for names. Echo? What's, do you guys hear an echo? Seven. Use my, all right, you're good. I'm gonna use Merab. Right, is that how you spell it? M-A-H. All right, so you're gonna be a friend to Bilbo here, and you have an address. What's the address? It's right here. When updating your flow JSON, always remember to remove the 0x from the start. And we're gonna add a key. Cool, cool, cool. What's the format? The format is exactly like we did for Bilbo. And we just gotta paste in the private key for this account. All right, so we added a new account. It's there, it's accessible. Let's leverage this script and see what we get. So I wanna look at the account address, go here and run a read inbox for Merab's account. Okay, run this, false, all right? So here, I wasn't bamboozling anyone. This actually works. And what that script does is it just checks if we create an inbox or not. All right, so let's create an inbox to finish this off. We're gonna use our newly created account, thanks to the chat, and we're gonna add inbox there. Okay, so everything seems fine. So previously, the result was false. Let's check if it's still false. Boom, it's true. So we created an inbox, we assigned it to the person, and we sort of went through a little bit of how to work with the CLI. This is fairly easy for anyone to do as long as you install the Flow CLI. So the way to do it, you go to the Flow docs and click on Flow CLI, and you'll get an instruction for how to install this. Okay, if you want to get started with some Cadence code, an easy suggestion would be to just go to Flow Playground, play.onflow.org, and click export. All right, so this will download a folder with some Cadence code already in there. Let me open up that folder. All right, so we have, this is the contents of what we just downloaded. So it has some Cadence in there, and you can open up this folder. So I'm gonna open that up right here, CD, and then we go into the Cadence folder. While there, you can initialize your Flow CLI, and you can sort of get going. Keys generate, you know. So this is kind of an easy transition from Flow Playground onto the CLI. And once you get familiar with the basic concepts of Flow, of signing transactions, of creating accounts, of generating keys, then in a few days you'll see that you're sort of ready to take it a step forward and start building real apps. I think my video's been stuck all along. I didn't even notice. All right, so this completes today's session. We covered a little bit about playgrounds, a little bit of what a contract is, thanks to Jacob helping me explain that. We created a Jacob Talks contract for Playground. And then we transitioned into the Flow CLI, and we got to experience a little bit of what it feels like to send these transactions manually. All right, so that's the topic for today. If you want to review, please feel free to message on Slack in the Flow Developer Hours Slack channel. But yeah, that's it for me for today. Tomorrow we start half an hour early, so 10:30 p.m. for Singapore time. We'll have a guest host, Pan, and he's gonna walk you guys through, finish up the presentation that he did for you guys during the opening ceremony. Oh, I did get a question before finishing here from Arab. He says, "Hey Morgan, can you briefly explain with example apps best NFT collateral based project?" Wow, so this is a good question. However, this is getting a little bit outside of the scope here, and I'm gonna ask Justin and others at Mercury to give me a hand with that, and we'll take it offline to explain this. All right, thanks everyone for taking part, for being active in the chat. I love that. I love seeing it, and we're gonna catch you tomorrow, 10:30 p.m. Pine is going to join us. I hope you guys join us, and yeah, keep coding and keep being active. Thanks, and from Morgan, I'm signing out. Bye now.